Howdy, today in Flipping Science we're looking at unit conversions. So we're going to be using this summary conversion table to help us out. It's not going to give us all the answers, but it will help us out a little bit. We're going to mainly be focusing on kind of this end of the spectrum, looking at converting parts per million into parts per billion, but we're also going to focus on using our SI prefixes to answer questions. Big things to remember: if you're going from a smaller unit to a big unit, you divide, and if you're going from a bigger unit to a smaller unit, you multiply. What I mean about smaller or bigger, so a gram, for example, is smaller than a kilogram. So that's what I mean when I'm saying smaller or bigger. So that's what we're going to be using. So we're going to do some examples, and I'm going to use the light board to help me. So the first example I'm going to use is this one here. I'm going to convert 2.5 kilograms into grams. So to help me out, I'm going to be writing what's going to happen. So I'm going from small to big. If I go from small to big, that means I divide. If I go from a big to small unit, then I'm going to multiply. So the first question says I'm converting 2.5 kilograms into grams. So 2.5 kilograms, and I'm going to be converting that into grams. So I need to figure out my conversion factor. I'm starting with a big unit, and I'm going to a small unit. So in that case, I'm going to be multiplying. Right? And I'm going to be using SI prefixes here, and I'll just pause it for a second to explain. So a kilogram, kilo is times 10 to the 3. Gram is times 10 to the 0, they're just grams. So our difference between these two is 1,000. So 10 to the 3 is 1,000. So that's the conversion factor that I'm going to use in answering the question. So there's 1,000 difference between 10 to the 3 and 10 to the 0. So I'm multiplying 2.5 by 1,000, and that's going to give me 2,500 grams, and that's going to be my answer. There's my smiling face. Next example I'm going to do is this conversion down here, where I'm going to convert 320 micrograms into kilograms. So I'm going to write out the question first. I'm changing 320 micrograms into kilograms. I'm just going to make a note that I'm changing a small unit into a large unit. So a microgram is much, much smaller than a kilogram. And if we're going from small to big, then we have to divide. Now I'm going to write out 320 micrograms in grams, and I figured that out using the SI prefixes. So here we have microgram, which is times 10 to the minus 6. So to turn that into grams, I need to move the decimal point 6 places. So I started with 320, so I move it 1, 2, 3, 4, 5, 6 places, and now I've converted the micrograms into grams, and that's a handy unit to have. I'm now going to do our division, which we figured out up here, and I'm going to divide by 1,000. The reason why I divide by 1,000 is because we have 1,000 grams in a kilogram. And I did the calculation offside. We get 3.2 times 10 to the minus 7 kilograms. So where does the 1,000 come from? There are 1,000 grams in a kilogram. So that's the conversion that we had before, but instead of multiplying, this time we're dividing. So another example question says the concentration of lead ions in one sample of wastewater is 4,000 parts per billion. State the concentration of lead ions in parts per million in the wastewater. So we're going to be converting 4,000 parts per billion into parts per million. So I'm converting parts per billion into parts per million. Right? So a part per billion is much smaller than a part per million. A million is 1,000 times different. So we're going from a small unit to a big unit, so that means that we have to divide. Right? So we're going from times 10 to the minus 6 times 10 to the minus 3, so again that's 1,000 difference. So part per billion is micro, part per million is milli. So if we look at our SI units, if we look at a part per billion and we work our numbers back, we've gone 1,000 times smaller this way and 1,000 times smaller again. So that's two lots of 1,000 smaller, so that's times 10 to the minus 6. So a part per billion, another way of thinking of that is a microgram per litre or a microgram per kilogram. Whereas parts per million is milligrams per litre or milligrams per kilogram. So there's 1,000 difference between these two. So my conversion factor is I'm dividing by 1,000. So now I write down what I have in the question. So we had 4,000 parts per billion in the question. We divide that by 1,000 and we get 4 parts per million. So 4 parts per million is 4,000 parts per billion. Our next question says a person drank a beverage containing ethanol. The concentration of ethanol in the blood after 30 minutes was 10.53 micromoles per litre. Convert that concentration into parts per million, and we're given the molar mass of ethanol as 44 grams per mole. So let's write that out. So we've got micromoles per litre, and we need to turn that into, if we look at the question, parts per million. We're starting with micromoles per litre and asks for parts per million. So I'm going to write out what our units are to start with, and then we're going to start doing some conversions. So we've got micromoles per litre, and to convert that initially I'm going to multiply it by the molar mass of the ethanol. Now the unit for molar mass is grams per mole. So if we have a look at this, we can see that we can start to cancel out some things. So if I so I can cancel out the moles on both sides there because I'm multiplying and then dividing by moles, so that doesn't mean anything. So now my unit is micrograms per litre, which is a much more useful unit to use. So a microgram per litre, it has another name, that's a part per billion. So remember, micro is times 10 to the minus 6, so microgram per litre is a part per billion. So that's a handy thing to have. So now I need to turn part per billion into part per million, and we just had the conversion there, we divide by 1,000, that's in the question that we just did. So now that I have what I need to do, I can shove in my numbers and I can find my answer. So we had 10.53 micromoles per litre. We're going to multiply that by the molar mass of the ethanol, which we were given as 44 grams per mole, and we get 463 micrograms per litre. Then we need to divide that by 1,000, and that will turn it into parts per million, and there we go. So there's our answer. So it's very handy when you're answering these questions to work with units to start with to see if you can get the units into what you want. So part per million is what we wanted to end up with. We did that by converting to parts per billion by multiplying by the molar mass up here. The next question says 3, 2, 1. The next question says calculate the mass in milligrams of lead nitrate needed to prepare 250 mils of 150 part per million solution. So we have our concentration down here, 150 parts per million. We need to figure out how many milligrams of lead nitrate we need to make that. And the other thing we need to know there is our volume, which is 250 mils. So I'm going to start by figuring out how to convert parts per million into milligrams, which is what we want. So a milligram per litre is a part per million. So parts per million is milligrams per litre. That's a very important thing to remember. So if we times that by the number of litres that we have, or that we need, then that means that we just have milligrams by itself. Okay, so I can cancel out the litres because I'm dividing by litres here and multiplying by litres there, so I can just cancel those out. And that tells me how many milligrams I have. So if I look at my question, 150 parts per million, and then I'm going to times that by the number of litres we have, which is 0.25 litres, and I'll explain that in a second, and our answer is 37.5 milligrams. So 250 millilitres is 0.25 of a litre, it's a quarter of a litre. So that's how I figured out the conversion factor here, to figure out what that one there was. So we need to have that in litres so it's in the right unit, or otherwise we wouldn't get the right conversion at the top here. Our next question, we have a sample of potato of mass 0.45 grams. It's been dissolved in acid, filtered, and then made up to 10 millilitres. Blah blah blah, we found absorbance, and we found the concentration of cadmium in that sample was 3.5 parts per billion. So the first question says, calculate the mass in micrograms of cadmium in the 10 ml sample. So that's where we're going to start. So we're turning the parts per billion from cadmium into micrograms, because that's what the question says. Calculate the mass in micrograms of the cadmium in the 10 ml sample, and we had 3.5 parts per billion. So parts per billion, I said this before, a part per billion is a microgram per litre, so that's the one to remember. So parts per billion is milligrams per litre, part per billion is micrograms per litre. So if we times that by how many litres of solution we have, we will get the number of micrograms that we need. So again, we're dividing by litres here, multiplying by litres there, so they cancel out. So now I write in my numbers. So I had 3.5 parts per billion. If we look back at the question, so 3.5 parts per billion. This is the volume of water, and I'll explain that later. So that's our volume of solution, so our number of litres. I did the calculation offside and I got 0.035 micrograms. So there should be a micrograms here, but I forgot to write it. So where did we get to 0.010? If we look over on our question, there was a 10 ml solution, so we need to convert 10 mls into litres. So 10 mls is 0.010 litres. Last bit says, determine the concentration in parts per billion of cadmium in the sample of potato. So we're going to use parts per billion, and we're going to use our mass of potato that we started with, 0.45 grams up here, to answer this question. So I'm going to write out my units to start with. So I'm starting with parts per billion. A part per billion is a microgram per kilogram, or a microgram per litre. I'm just going to rewrite that again so we can see where the kilograms go. So they go underneath. So we're dividing by the number of kilograms. Now, from my answer before, I had 0.035 parts per billion. So now I'm going to divide that by the number of kilograms of stuff that I have. That's 0.00045. We had a 0.45 gram sample of potato. and I'll just do the calculation. So we get my answer of 78 part per billion once it's rounded off. Where did the 0.00045 come from? So like I said, we had 0.45 of a gram. So 0.45 grams, if we turn that into kilograms, because our unit here, we needed to have it in kilograms down the bottom. So we're going from a small unit to a large unit. A gram is smaller than a kilogram. And if we do that, we have to divide. And the factor of going from gram to kilogram, so 10 to the 0, so 10 to the 0 to 10 to the 3, so it's 1,000. So we have to divide by 1,000. So 0.45 divided by 1,000, that gives us 0.00045. And there we go. And that's how we calculate our answer. So today on Flippin Science, we did some example questions where we looked at doing unit conversions, mainly involving parts per million and parts per billion. So that's it for Flippin Science today. See ya.